In part B, we are given the diagram for the setup of the experiment, and we're given this graph that shows the variation of current in the ammeter with the voltage. We're asked to explain why current is zero for the very large negative voltages. And well, it's because when we have very large negative voltages, the electrons are repelled from the collecting plate. Collecting plate. So no electrons reach it. So if there's no flow of charge, it means that current is zero. And the reason they are repelled is because if we look at the circuit, this would be the positive side and this would be the negative side. So electrons would be attracted this way. But if we flip it, so if we make the potential negative, then this becomes negative and this becomes positive. So the electrons will be repelled from this side, so they will be pushed against their will to jump over. And then in part 2, we need to say why it approaches a constant value for large V, and what kind of the same reason. So if this becomes very positive and this becomes very negative, then almost all of the electrons will be able to jump across. So electrons are attracted by the collecting plate. And what this will mean is that eventually all electrons reach collecting plate. So there cannot be any more electrons jumping the gap, and therefore the current, so the number of electrons will be the same. The current constant, as we will have no longer any more electrons jumping across, or the number of electrons jumping across will not change anymore.